Hello boys and girls, and welcome to lesson 5 from chapter 2, percent of change. We're going to look at how much numbers change by percent. Okay, this lesson can be found on page 143 of your textbook. Let's take a look at the real world link. How does this apply? The Indy 500 is a car race, boys and girls. It's a race where cars do 500 laps around a track. Okay, the Indy 500 is one of the world's great motor races. The table shows the average speed of the winning race cars for various years. So here we have a chart, and it's kept on how the time or the speed that the cars that have won. In 1922, the car that won was traveling at about 94 miles per hour. In 1955, it was traveling around 128 miles per hour. And in 2010, most recently, 162 miles per hour. So clearly it's been getting faster. But how much faster? That's what we're going to look at today. When we say percent of change, I want to know what percent of difference goes from 94 to 162. Now, keep in mind that if we want to find the percent of any number, we can simply go like this. Like we can say, let's say I wanted to know what the percent of 94, okay? 94 is the percent of 162. Okay, let's say I want to know. So I take my 94 and I simply divide it by 162. That's going to give me about 0.58. It gives me a decimal, right? But this 0.58 is a percent. This means 58%. So 94 is 58% of 162. That's not what we're looking for, boys and girls. We're not looking for that. We're looking for the other number. We're looking for the other percent. We're looking for it would be 42%, I believe, right? For the rest of the 100. We're looking for the rest of it. We're looking for the difference from this to this. In order to do that, I need to know what number the difference between 94 and 162 is. So that's easy to find. When you just take 162 and you subtract 94, you'll get the difference. And we know that's 68. Right? 68. Now we can try to see what percent 68 is of 162, and that's going to tell us our percent of change. So 68 divided by 162, right? 68 divided by 162. 68 is 0.42, or remember we write this as a percent, make it out of 100, it would be 2, it would be 42%, okay, as we said before. And this, boys and girls, is our percent of change from year to year. Now let's try for the difference between 1922 to 1955, this difference right here, and the difference between 1955 to 2010. So we're given the equation. They want us to, the top number of this fraction, okay, is going to be the speed increase from 1922 to 1955, 1922 to 1955. So let's find the difference between those numbers by going 128, by writing 128 minus 94. That'll tell, minus 94, sorry. Okay, that'll tell us the difference, okay, between these two numbers, right? And we know that's 34, right? So that's what needs to go in the top number. It's the difference between those 2 years, and that's what we're going to have here, right? So we have the number 34, okay, 34 right there. And we're going to divide that number by the speed in 1922, by this speed, because we're trying to see how much it increased and what percent of this did it increase by. So when we do that and we divide 34 divided by 94, we get 36, 0.36, right? We get 0.36, and as a percent, we all know that is 36%. Right? Let's do the same with the comparison between 1955 and 2010. So again, we look for the difference from 128 to 162 by subtracting 162 minus 128, right? So that we find the difference. And it looks like we got exactly 34 again. 34. Alright, so let's write that down here. That's 34, right? And we're going to divide it by 128, which is the number here, because we want to find out how much it increased by this number. What percent of this number did it increase by? Okay, when we do that, we will get a decimal point of 0 decimal point is 0.265. When we make that a percent, we jump over 2 times and it's 26.5, or we simply round it to 27%. Okay? This, boys and girls, is what we call the percent of change. How much percentage did it increase by? Okay, in speed. Now, why are the amounts of increase the same? Yes, they are the same, 34 here and 34 here, but the percent's different. Well, because this is a percent out of 94, and this is a percent out of 128. So the starting years are different. So go ahead and write that down. They're different because the speeds for the starting years are different. See, this is different than this one. So 34 out of 94 is 36%. 34 out of 128 is 27%. So they're different. As a key answer, make sure that you write the decimals here the same way I wrote them, and arrows pointing at the percents. Okay? Okay, I'd like to draw your attention to the top of page 144. 144. Okay? Where we're given a key concept, and the key concept here is the percent of change. Percent of change is a ratio that compares the change in quantity to the original amount. So, as we were doing with the speed, so let's say, I don't know, at the age of 10 you could eat 5 slices of pizza, but at the age of 30, now you're able to eat easily 10 slices of pizza, let's just say. Okay, what is your percent of change? Clearly, your percent of change is 100%, right? Oops, that's dollars. Okay, you were able to eat 5 slices before, now you can eat 10 slices, so it changed by 100% of this original amount. That's what they mean by that. And to figure out the percent, this will give you a decimal, you take the amount of change, how much it changed by 5, remember, and then we divide it by the original amount, which is 5, so it will be 1, and 1 whole is 100%. Okay, let's see. Percent of change can also be used to show increase or show decrease. When you compare the amount of change to the original amount in a ratio, you are finding the percent of change. The percent of change is based on the original amount. How much did it change from the original amount? If the original quantity is increased, then it's called a percent of increase. If the original quantity is decreased, then it's called a percent of decrease. Got it? Percent of increase, you write it right there, how much did it increase by, divided by the original amount, or percent of decrease, you write it right there and you write the original amount. And that'll tell you how much it increased or decreased by in percent. Okay, quickly let's take a look at example 2 on page 145, where we see the example of a radio. Yusuf bought a DVD recorder, DVD recorder for $280. Now it's on sale for $220. Wow, it went down about, exactly $60. Do you see that? From $280 to $220 is $60. Find the percent of change in the price. Round to the nearest whole percent if necessary. Now let's see. We found the difference and we said it was $60. Great. In the equation, we put the amount of decrease right there. We put $60, right, over the original amount, and the original amount we said was $280. When we divide that, we get 0.21 approximately. You see that right there, approximately. So then we change it over to a percent by making it 21%. Okay, let's try these. On page 145, we have A and B halfway down the page. Find the percent of change from 10 yards to 13 yards. Boys and girls, we see that it went up by 3 yards, right? 3 yards. Sorry, let me move this out of the way. 3 yards out of 10 original yards. You see that right there, right? Out of 10 original yards. Well, we know that this is 3/10, and 3/10 is 30%. Okay, this one was easy to do in our minds. Now, let's see here. The price of a radio was $20. It is on sale for $15, okay? So what is the change difference? How much did it go down by? Let me move this down a little bit more. The difference between 20 and 15 is 5. So 5, and the original price was 20. Well, if you simplify this, boys and girls, this is 1/4, is it not? And 1/4 we know is 25%. We've memorized that, we know that off by heart. So what is the percent of change? There it is, 25%. So the first one was a 30% increase, right, in the yards, 30% increase, and the other one was a 25% decrease. Please write these in where they go in the answer along the margin. A is 30% increase and B is 20% decrease. These are key answers, okay? You can even circle the whole thing after you write it. I will be looking for that. Another key concept at the bottom of page 145 is the percent error. Now, sometimes this happens, boys and girls, when we're estimating. For example, take a look here. Okay? Here we have an example of the gumballs. Finding the percent error is similar to finding the percent of change. Instead of finding the amount of increase or decrease, you will find the amount an estimate is greater or less than the actual amount. Suppose you guess there are 300 gumballs. You guessed there were 300 in here, but there are actually 400. Well, what's the difference? 100, right? There's an error of 100. You take your 100 and you divide it by the original amount, by the right actual amount, you divide it, and that's going to tell you that there's a margin error of 25%. So it's essentially the same thing, boys and girls, except here we're using it to find an error, and we call it a percent error of 25%. If it feels like I'm going too fast for you, always remember you can stop, pause, rewind, and watch it again. Listen carefully. So knowing that it's the same idea, a percent error, as finding an increase or decrease in percent change, let's take a look at this. Now, I want you to take the time now to read this word problems. Take a look at how it's the difference is found. Take a look how the numbers are computed and how the percent is found. Okay, so therefore the percent error is 10%. Now, take a look at that on your own. Please pause the video. I want to do this one with you. Okay, here we're going to find the percent error. Find the percent error if the estimate is 230. So let's say somebody estimated $230 was the price of something, and the actual amount is 245. Round to the nearest whole percent. What's the difference between 230 and 245? If you're saying $15, you are correct. That's our error right there, 15. But what percent is that? We take the actual amount, the real amount, okay, you see it right there, actual amount, okay, and we divide it. Don't forget that we have to round it to the nearest whole percent. Now, when I divide this, I get 0.006, 2, and so on. But we want to round it to the nearest whole percent, so we jump 1, 2, and I get 6.1%, but we don't write the 1, so we just write 6% is our margin of error. Okay, boys and girls, let's do the guided practice in class together. And you can go ahead and do the independent practice on your own. You can do the entire page of 147. That'll be the only thing. Now remember, you can always look at the examples 1 and 2, and they'll explain how to do this. As well as down here, you look at example 3, and it'll give you an example of how to do these, and examples 1 to 2. Okay? See you in class.